The 7950 from our friends at AMD is an amazing processor. The problem is it consumes so much power. It generates so much heat that it actually makes itself perform lower than it regularly can. So in this video, I'm going to show you not only how to make the processor perform better, I'm going to show you how to undervolt it so that you can actually consume less power, generate less heat, and spend a ton less money. I'm also going to show you how to reset your CMOS in case you run into some issues along the way. So without wasting any more time, let's get started. I've been testing on this for quite a few days, and it's incredibly frustrating because I have to keep resetting the CMOS when it fails. I'm going to try to keep it incredibly simple for you. That way you don't have to spend the number of days and so much time. I'm going to try to keep it incredibly short for you, though it still might be a little tiny bit long. Anyway, let's start with a base. At the beginning, we'll install AMD Ryzen Master, Cinebench 23 for testing, and I have a bunch of others. And then, of course, we're going to use HW info and sensors just so that we have some temperatures here. So I'm going to open up Cinebench R23. We're stock right now. Everything is stock. We haven't undervolted or overvolted or overclocked. And we have a good liquid cooling unit, and it's quiet right now. I'm going to start multi-core. Now you hear how loud it got, and it's not because this is a bad liquid cooling unit, it's because it has to speed up everything to compensate for that heat. Now you can see right over here, the CPUs hit 95, 94, 95, 90, and then over here we can see that it has hit up to 5.7 gigahertz. And with that, we've gotten a score of 36,818. Now just realize, just because it passed one benchmark does not mean it's stable. You're going to have to test with many benchmarks and play some games and do some of the productivity stuff you might regularly do before you find out if it's stable. This helps us get a baseline. So I'm going to close this out, and then we'll open up AMD Ryzen Master. For some reason, it likes to go in an odd corner over here. You have to click, hold, and select Ryzen Master maybe a few times before you can actually get it out of there. All right, this is the basic view. In the basic view, you'll see the temperature, the current temperature, and the maximum temperature. The maximum temperature before it starts to throttle is 95 degrees C. It's going to throttle well before it hits that though. Then the current CPU clock, you'll see that moving around a lot, and the maximum CPU clock. It will barely ever hit 5.8, as you see right up here, 5.7, regardless. And the current CPU voltage, I've seen it go as high as 1.4, and the maximum, there is no max, is set to auto. Okay, this is the basic view. Under advanced, you can do so much more, but it's going to be incredibly overwhelming. I'd like to stick to over here for now. And here we go again. Okay, all right, so first off, for control mode, we'll click manual under control mode. You'll see the CPU clock speed of 4.5 gigahertz. And a CPU voltage of 1.4. Where I found the sweet spot to be to start is bringing this down to 0.975, and I'll just click apply here. And up here, 4.7 gigahertz. Now to test that, it has a built-in testing utility that's decent. So we'll click apply and test. It'll only take a few seconds. And then we'll close this out and just open it again. Click sensors and minimize here. That way it'll be current. Okay, it's not incredibly stressful, but it's a good way to do basic testing. Again, one application won't tell you if you're stable, just the base. So then from here, every time we want to raise the megahertz, we'll do it like something like that, and then we'll raise this 0.010. All right, so apply and apply and test. So now we see that works. So now what we'll do is whenever we raise, let's say 50 megahertz on the CPU, we'll raise the voltage down below 0.010. Now you could be brave and you can keep raising 25 megahertz and test, 25 megahertz and test, or maybe 50 and test. But then you run the risk of having to reset the CMOS. And that takes a very, very long time because then you have to reset this and then start from scratch. Take good notes because you could waste so much time. We're gonna go ahead and fast forward to the last good test I've had. You can actually see it right over here. I'm not going to load that profile, but I'll close out of here and then we'll raise this 5.1 gigahertz, and then we'll raise this and then click apply here. Then we're gonna click apply and test. Perfect. Now you see the core clocks were 5.1 all the way through. So that's beautiful. Again, we're not 100% stable that we know of, but now I'm gonna go ahead, close out of here. I'll just minimize this. We can close it, but I'll leave it open. I'll open up Cinebench and then we'll start a multi-core test. So stock speeds, we received 36818 in Cinebench R23. And then you saw all the reds that we had everywhere down the CCD, but then undervolting it, potentially losing performance, we actually went up to 36912. So we gained performance and we saw no reds within the thermals. So we did better processor wise. We became more efficient, sped things up and lowered the temperature of the CPU. That's awesome. Lowering the temperature of the CPU also requires less power. Let me show you what I mean. So I just did another pass at stock voltages and it's not exactly the same, but we got 36,799. At 36,799, the maximum wattage consumed on the entire system was 440 watts. Your electricity bill is going to go up a little bit with this system. So setting it back to the way we had it before, we'll open up Cinebench again and just run it. All right, so now we received 37,211, so I actually went higher than 36,912 and we had the same score. And now we're at 334 watts. So let's say 100 watts less with more performance. I'll take that any day. Now remember, this means that potentially your system is unstable. Just because you passed one round of R23 doesn't mean you're stable. So what I like to do is, to help me a little bit, is I go to minimum test duration and now I bump it up to 10 minutes and I do another CPU multi-core test. And I'll go ahead and open up this again just so that we can see if anything gets in the red. So I'll be right back. We've done 10 minutes of testing and now we got 36,972, so it's doing great. We can see here, and I opened this up so that you can see that every single core hits 5.1 and it actually stays at 5.1, which is beautiful. And you see nothing down here in the reds, everything is perfect. So now what I like to do after that is I come over here and I test for 30 minutes and I start. 30 minutes is going to tell you if you have a very good chance of surviving all your daily use or if you're going to have some issues. Again, it's not perfect, but at least it's testing. So let's see if this passes. 30 minutes and we can see right over here, it's still doing its thing, but it just finished 30 minutes over here. We can see 5.1 gigahertz across all cores. Nothing has gone into the red down here. 37,035, it looks impressive. Everything's in the 60s. The highest it got was 75.9, 77.9. That's beautiful. And again, nothing in the reds here. I think this is solid. But again, we won't know until we play with it some more. It might not blue screen or crash for another week or so until we actually find out if this overclock is stable. So just make sure you keep testing, just maybe for a few more days, just to make sure everything's good. After that, you should be okay, but there is the possibility something can throw it off. Make sure to record those benchmarks. And if you ever make a change in the BIOS or software wise inside of Ryzen Master, make sure to record that as well. In case you run into an issue that I blue screened and I can't get back in Windows, it won't turn on. Let me show you how to reset your CMOS real quick. It won't take very long. So first, we're going to want to make sure we shut down the machine. Now, on most machines, you can just reach in and remove the CMOS battery or actually pop in a jumper and reset the CMOS. But in this case, we don't have that ability. So removing the side panel, you can see that we have a 4D90 blocking where the battery and the jumper would be. Not a big issue. We just have to remove it. But before we actually touch anything inside of the system, we need to make sure we either flick the switch on the power supply or just remove the power cable altogether. I'm just flicking that switch. Then I'll also remove the HDMI or DP cable from the card. And now we'll remove the graphics card. Before we actually touch the card, just put your hands on some metal inside of the case. That way we ground ourselves so we get rid of the ESD. We don't want to fry it. And I'm just going to unscrew back here. Now we'll remove the 12 volt high power connection. Just push in that little piece up here and it comes out. You might have to pull a little hard. Now, I can't show you the clip that's actually locking the card in place. I'm gonna reach around and push it, but I'll show it to you as soon as I remove the card. This is the little clip that was holding the card in place. It was up like this. To remove the card, I had to push this down, which unlocks the PCIe slot. This is that piece that piece of plastic locks into. It just goes click right in here and locks the card in place. So right here, you can see that CMOS battery. It's in a weird position. So I'll just push this piece of metal in with my fingernail and that releases that little disc battery. And then I just pull it out. Kind of looks like a magic trick. Now with it removed from the system and the system powered off because we either flicked the power supply or pulled the power cable out, we'll give it between 1 and 5 minutes. That way to make sure everything is discharged. While we're waiting for that, over here, right there, we'll find the left 2 pins of the 4. Those are the left 2 that we'd put a jumper in, or we use a screwdriver to just come in here and short the 2, and then when you turn it on, the BIOS is wiped. So I don't recommend doing that, but I did want to let you know that that possibility is there in case you needed it. Again, be extremely careful with that. Now with that, we can go ahead and put the battery back in. We'll place it first on this side, slide it in on the right, and then push it down so that it locks underneath this piece of metal. All right, and we're good to go. And don't forget, when you're plugging the 12 volt high power, make sure you hear a little click. Perfect, nice and loud. After resetting the CMOS, we'll flick the switch back on first and then turn it on. And remember, it takes a minute because the memory has to retrain the very first time you turn on an AM5 system. And we make all the same changes we've done already, maybe quite a few times on my side especially. So in this video, I've shown you how to take your 7950 from being a power hungry money hog that wants to eat up all your electricity bill, wants to raise your AC bill, wants to take over everything and tame it a little bit and actually give you more performance when we tame it. So I've shown you how to completely update your system with what you already have. Now this doesn't only work with the 7950, it works with others, but I've given you the method on how to do it. Start low and then in increments, in 0.010 increments, start bumping it up. Start raising your CPU speed, let's say 25 or 50 megahertz at a time. When you start noticing errors, start bumping up your voltage 0.010 each time, and then that way you'll be able to get the perfect balance between power and performance like I've shown you here. It's awesome. I warn you, it will take you a while. And for those instances that you do run into a blue screen and you can't get back in Windows, I've also showed you how to reset the CMOS, both the jumper way and the battery way. The battery way is a lot more safer than the jumper way. I don't even know if I still have a jumper anywhere around the house. I'm sure I do somewhere, but you can use a screwdriver as well. I just wanted to show you how to do both ways just in case. So if you're curious on how I built this system, check out this video up here and many more coming soon. Iggy with ThisBytesForYou out. See you guys.